Well, hi, good morning, and thank you so much for joining me here in my shop. Today is August 5th. Looks like it's going to be a hot day, maybe with some rain. And boy, we need rain here in Ontario. It's been a long time. It's becoming a farming problem for sure. So let's hope for some rain. Now, about this radio. So the good thing is, it's now working at, just throw out a number, 75%. And because of that, I can now go forward and make more changes in the radio. If the change I make is detrimental, I can tell, because the radio won't perform at 75% anymore. And if the change I make improves it, then it's going to run a little better if we can detect that. Probably can't detect a small change, but the main thing is making a change, like changing out a capacitor and then having the radio stop working. If it wasn't working in the first place, I wouldn't know that it happened. Something similar to what went on with the transformer down here, which I was really quite anxious about attempting so early on in the process of fixing a radio. It seemed to me that this, was going to be a roadblock because of the problem with the slug in here, and unless this was dealt with, nothing else was ever going to be dealt with. So that's what pushed that right to the front. And since then, this has been a big question mark, and it's just made everything very complicated. But in any case, at this point, certainly on the broadcast band, the only band I checked, but I'll bet you all the rest work too, the radio is functioning good enough now. So I have options going forward here. I have alignment options I can undertake right now. I have a world of capacitors in here that could be fiddled around with and replaced. I could continue another element of the alignment, which I would not do at this point, but it is an option. I could start fiddling around down in here. I don't know much of what goes on in here. I've never fiddled with this part of one of these radios. So probably a good way forward is to find one of these molded capacitors and replace it and test it outside the radio, and then use that as an example of what the rest of them are probably like. And the best capacitor for that is going to be, and I don't know for sure there is one in here, well, there should be one, a blocking capacitor that blocks plate voltage from reaching the grid of the output tube. That guy is worth testing, and because of the way the radio operates, you're able to test the quality of the capacitor right in the radio by doing a very simple test. And if this capacitor that I'm going to test, assuming it's in here, proves to be a little questionable or a little leaky, then we're on our way to replacing these molded ones. And there's quite a few of them in here. So let's find that capacitor, the grid protecting capacitor, or grid blocking capacitor. Let's take a look on the schematic and see if we can find it here. Well, this is going to lead us right into a very tricky area of the radio right up in here. So I'm going to zoom in on this output part of the radio, and what's going to be tricky is this component package shows up. So notice the dotted line here, the square package that's being marked. So if we look, we see the grid of the output tube. We see something unusual, and that's this. This is unusual. Why they have this exactly, I'm not sure. There's no resistor coming down here. But if we look inside the package, there's the resistor coming down here. There's the blocking capacitor. There's the resistor that is, that's a big one. That's a little big. In the plate circuit? Well, there's a big one there. And on the screen, we have also a bigger resistor on the screen. 22 volts here. Oh, I'm looking at the wrong one. What has happened? We're looking at the other tube. It doesn't matter. Keep going, Jeff. Don't worry. 22, 25. Normally you have a pretty low voltage on the plate of the detector tube. I believe the reason is the higher the plate voltage, the more noisy this tube becomes because of the diode. But I'm not sure why that is. But typically these are low. So only 25 volts here. Only 25 volts pushing on this capacitor, which is buried inside this package here. So we can't really replace this. Well, if this were to be shorted out, you could replace it with a, I don't know about that. Put the capacitor out here. You're past this resistor. You might have to just sacrifice this entire package and rebuild this with all these parts. Okay, well, why did they do this? Well, this makes it really easy. This arrangement of parts is typical in almost every radio, and so some part manufacturer, or perhaps the radio manufacturer himself, could do this. Package these together, and then it's real easy to build them into the radio. That's a key thing. There's another one over here, a little one over here. These things became more and more common as time went by, and you pretty much find these in almost every radio in the I guess 70s or later 60s, and transistorized radios have stuff like this too. So, okay, what I'm proposing to do is it says 1.2 volts here. How come it doesn't say negative? Because this reading is not taken. How do you take this reading? So this voltage is taken to the chassis, I'm pretty sure. Can't read a DC voltage to the chassis. It must be to B minus. Where's the notes? We must read the notes. All voltage is measured with VTVM between tube socket terminals and B minus. Voltages are DC and positive unless otherwise specified. Okay, so that being the case, we know how they did this reading. The important voltage from the tube's point of view is the potential difference, or the voltage between the grid and this heater, which is acting as the cathode. I'm not sure I can just measure from here to here, though. I mean, there's 3 places to measure, and they all have elevated voltages, and there's no grounded terminal. There's no, I don't think I can do it here. So consequently, you have to rely on this reading. And although it's positive, I don't think the grid is positive to the cathode. I think it's positive in the reading. I guess what we would do is read this 1.2, and if it's like 2.4, assume this guy is leaking a bit of voltage over from here. Or, yeah, because this will go more and more positive. Yeah. Okay, so we're going to test this capacitor in this package by making this voltage measurement on V3. Okay, the VTVM is ready. 5 volts positive, and this is V3 here. This is the 3V4, I think it is, and it's pin number, let me just double check and make absolutely sure, pin number 6. Pin number 6, 7-6. So here it is coming out of the package. The package has numbers on it here. They're not in order. Something 4, 2, look like 9, 6, 5. 6 is the one that's coming up here. So this is the guy. Okay, I'm all ready. Here we go. We're turning on the radio. Don't think the antenna booster switched on down here, so we may not hear. Is it really that quiet? It is. It is that quiet. Okay. What be the voltage here? So watching the meter, the expectation is 1.2 volts. So on the 5 volt scale, 1.2 is just up about here. It's in the right spot. Okay, so that says leave that package alone for now, and we can't draw any conclusion about any other capacitors from that test. But good thing, that package appears to be good. Let's just read up on this. Oh, wait a minute. Yeah, let's read up on this. It's got an asterisk after it. C11270. What is it about that one? Is it listed over here? Yeah, oh, here we are. On some sets, C11 is 220. When making replacement, use 270. Okay. Well, I guess that fits right in if I'm going to I don't think I'm not inclined to replace that one. I don't think. What's the size of it? 270. So this is probably well, wait a minute. Where is that? 270. I'm looking at the radio right now. There's no 270 there. There's no C11 there. Look at the radio here. So it's the same pin I just tested. Has the capacitor inside the package coming up on this wire, and then it should have another capacitor leaving here, heading where it was headed. I can't remember where it's headed. There's nothing there. There is nothing there. Huh. Okay, well, just leave it the way it is. Not, I wouldn't think, oh, we better add it in. I don't think I would do that, especially with the radio operating. Okay, so what we need now another capacitor that we can somehow become aware of its quality, and I may have to just remove it to do it. Let's look at the schematic and see if we can find some interesting ones, like these bigger ones. Bigger capacitor, bigger job, bigger problems. Well, not necessarily, but let's look at the schematic. So we have a couple we've already changed here, and that's of course the ones around the volume control. That's this guy, C7, and this guy. Now, can we find any more kicking around? All these tone ones I'm not too concerned about. So there's a 0.01 there. It's a bypass around here. I'm going to guess if you didn't bypass this resistor, you would lose a lot of output power if this is faulty. Can we test this? It's got a resistor right across it. Can we do something while it's operating and say, see, it's good? I don't think so. Well, let's try another one. AVC capacitor, this one here. So this capacitor is sitting in the AVC bucket. I guess I would call it the AVC bucket. This resistor is like a spigot, and you're flowing in charge through the spigot. You can't turn the spigot, it's fixed, but it's a very small one. So you throw the charge in, you squeeze it through this resistor, and it builds up in this capacitor, and then there's nothing to bleed it down. Well, okay, it's up. You can bleed it down very slowly through this gigantic resistor. That's a little odd. If we follow this wire, I'm pretty sure we will find it doesn't connect to, oh my gosh, what's it connecting to? Oh, all the antenna stuff. So what I'm trying to say, but not doing a good job of it, is the impedance on this side is very, very high. So a little bit of charge, fill the bucket up. Fill the bucket up with a little bit of charge. and that's what gives the time delay effect that this capacitor has on the AVC voltage. The AVC voltage is controlling the strength of the front end of the radio. In this radio, it's just looks like it's just doing. I think it's just doing the one front end too, the RF2. I think that's the only one that's being throttled with the AVC voltage. Okay. So I mean, if this guy's not working all that well, we won't really notice much. And how can I test this? A little tough to test it in circuit, or while the radio's operating. So. Yeah. The one I usually use is the one that we tried in the package before. 270, 0.05 here. Some stuff around the oscillator. Look at that, 0.1. A 0.1 all around the oscillator mixer. Look at them all around here. Let's find this 0.1. This 0.1 is C124. Can we see 124? See, oh, 124. You know what that means? It's up inside this box. I don't think we want to go up in there. Okay, this is not working out this way. Let's take a different approach. Different approach is just look at the thing and go, look at that big capacitor there. That's a little hard to get at. Look at this one. This one's easy to get at. What's it doing? It's, oh my god, I stuck my finger into a live radio. Did not get a shock though. That was stupid of me. Da 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 da. Now, if I was a wise video maker, I would go back and cut that part out. Then I wouldn't get comments about how stupid I am. It all goes. It's all consistent. Stupid, stupid. Okay. I like to make a big, when I make a mistake like that, especially one that I could have gotten a shock pretty easily from that, I like to make a bigger deal of it in my own life as I'm standing here, dwell on it, because it kind of charges my brain up to be smarter next time. I don't ignore my mistakes, basically. Okay. So if this guy's involved with the IF, wouldn't he be an attractive? This might be the one I was just looking for. Let's just take a look. In the first IF, back on the schematic here. First IF. Big honking capacitor. Where are you? Well, you know, it could be anywhere on these wires. I've done this one. Oh. No, this is part of the, yeah, I have done this. This is part of the 4-part capacitor, right. So it could be this one. I'll bet you it's this one, C1. C1, I can't read the size of it. Well, if that's C1, that's definitely worth doing. You take it out of the radio and test it out of the radio. I can't test it in the radio. We'll test it. We'll just replace it. It's only a single capacitor. Just have to find it. C1. Okay. C1. 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 Okay, now I got kind of, that's C1. This one right here. Connecting to this IF transformer here. And over onto the, looks like the end of this terminal strip. When I look back at it, yeah, that's exactly what it's doing. And it's a 0.01. Right? Wasn't that right? 0.05, Jim. Okay, 0.05. We're gonna cut this out, test it, and replace it. Okay, so I turned around, I looked at my bench, and I saw this. It looks like a clip. It looks like an E-clip. Sitting right here. Uh-oh. No idea where that might have come from. If it even came from this radio, I can't even be sure of that. Okay, so onward with the capacitor. So what we're going to do, we're going to cut it out. Stick a new one in there. I'm just going to cut it. That's good enough for now. I'll clean that up and solder it in. Let's test this thing. I'll clean that up and solder it in. In case I didn't say that so clearly. No doubt I got to clean up my bench here. Take a day and just work on cleaning up my shop. There we are. DC. Looks like it says 400 there. Okay, with 50 volts onto it. Now, I'm just trying to shade this so you can see the pie there. Here we go. Rate open. Next one. Rate open. 250 volts. Rate open. Okay, the capacitor is in great shape. It is in great shape. And it's probably indicative of the condition of the rest of them, although there's no guarantee of that. What this does is it really eliminates a justification for going through and replacing all these, because this tests the same as a brand new one. Let's give it another test. Since it doesn't appear to be leaky at all, testing it with for its capacitance can be valid, or should be valid. I like this little tester. So this says it's a 0.05, just a hair above a 0.05, and that's exactly what it's supposed to be. Okay, so all indications are no need to change, at this point, no need to change any other capacitors. There's no indication that it's worth doing. And the reason I would hesitate, and you might say, well, you're being silly, the more time you spend with a radio like this, or with anything, the more time you have to make a terrible mistake and ruin it. And so less done the better. That's my philosophy on this. And I really have no evidence that the existing capacitors are dragging this radio down. Now that may come later. They may be doing some alignment or something like that and finally conclude that its performance is being dragged down somehow. Wouldn't bet on that happening either. I'll make this as short as I can. Okay, so I'm going to solder this guy in. And then we're going to probably... it's pretty early, isn't it? It's not even 10 o'clock here this morning. So, probably, maybe we'll work more on the alignment of the IF and do a more professional job of it than what I did yesterday. And that is the first step anyway in doing an alignment. You can't do the other things. This didn't come out very good. You can't do the other things until the IF is straightened out. It's just not going on there very good. I think I can solder it. Just tuck this wire up a little bit. Yeah. Okay. Am I standing in front of the camera the whole time? Maybe I was. I think I made a little mistake here in interpreting things. And I'm not sure. No, maybe I didn't. Maybe I didn't make a mistake. Then why am I looking at this now? I'm looking at this now because I want to know where to hook up the oscilloscope, and I want to hook it up ahead of this, so in this area, right at the end of this. Okay, fine. No problem. Okay, hook it up right at the end of this. So we have this ground connected to the chassis here, down here. This is the input signal from the signal generator, grounded to the chassis. I'm going to put this ground on. It's got to go on the chassis too, or we're going to have trouble. I don't know. Can I get a good reading by grounding this? This should be on the B minus at this point, shouldn't it? Well, we can try it on the chassis and see what happens. I guess that's what we'll have to start with. So we'll put this on the chassis here. That's loose. Okay. this guy is going to go on the 2.2 megohm resistor, which is right here. And it's got to go on one side or the other. It's going on the... This turns out to be the capacitor I thought it was going at before. I think this is the ABC capacitor, I think. Don't quote me on it. Yeah, never quote me. And we'll put that there. So I believe the scope is now looking at the ABC output. Good. Ahead of the high value resistor, and not in the bucket side of things. You don't want to go look at the bucket. You want to look at the other side of the resistor. The bucket being this capacitor. Okay. I think we're ready to go. I got my tool ready. Got the other signal generator ready to be a marker generator, but I haven't got it turned on yet. So let's get the sweep happening here. I got a little more to set up. Okay, I think I'm ready now. So sweep generator's running back here, and we're sweeping from 400 to 500 kilohertz, right through the 455 range. We should see that on the scope that you're looking at right above here. I have the marker generator ready to be used. It's set to pretty much the correct frequency, 455 or so. This should help identify exactly where 455 occurs over here, because we can't be sure otherwise. It's very, very difficult to be certain otherwise. Okay, let's see, I've got this a little too high right now. And I almost forgot, I have to change the sweep here. So the sweep is now being generated by the sweep generator. Okay, just a little bit of housekeeping here. Okay. So I think we're ready. Here we go. Turn on the radio. Quiet enough now, I forget it's on. 110 volts being supplied. It's not on. Let's try this. Well, that was interesting. What happened on the scope there? Let me just reverse the plug. It should make no difference, but I don't know. Let's just reverse it. The reason for making no difference. Well, there's some weird stuff on there. The reason for making no difference is because this is not plugged into a regular outlet. This is plugged into an isolation transformer. So it's floating, if you like, but then I have these grounds attached to it, so it's not floating. The weird thing is, look at how flat this bottom is. And this is probably because I have this connection made to the chassis and not to the B-. So the question is, can I move the input to the B-? So the input actually is coming from this and this. Right now it's attached to a terminal on the capacitor, on the tuning capacitor. I'm uncomfortable here. I don't like what's happening. I think these grounds need to be on the B- to make everything work. But then the front end of the radio can be a little different. Better just let's just take a look at. I'm just going to stop for a minute and read up. Okay, there's some added complications here I hadn't really paid attention to, and that is these what they call dummy antennas, which are really interface circuits between your test equipment and the item under test, the device under test. So they like to call them dummy antennas. Yeah, I think that's a misleading term. I found it misleading all my life. So this is to make the radio, which is here, think it's hooked up to its usual antenna and not to a signal generator. Because if you just hook up a signal generator straight on, you disturb the radio circuits, and then if you make adjustments and whatnot, you'll be adjusting it for that and not for what it normally has. And that's the challenge here. Now, 15 and 10, and then 15 and 5. It doesn't seem like much of a difference to me. To whip antenna socket to chassis. To whip antenna socket to chassis. Whip antenna disconnected. This is for bands 1 and 5, and this is for all the rest. 2, 3, 4, and 6. There's a 7th band, isn't there? There's 6 bands. There's a 7th band. There's really 4, 5, 6, 7. There's really 8. There's really 8 bands. What happened to some of them got left out here? 7 and 8. Maybe they're done some other way. Now the other thing in the alignment instructions is to connect your output meter to the speaker. Now the advantage of this, there's a big advantage to this. So here's a speaker. If you look, this whole circuit is isolated away. It's not grounded or anything. It's just from the output of this transformer. It's not touching anything. So you can hook up your test equipment here. You don't have to worry about the ground or anything like that in this radio. Not all radios, but in this one. And you could just like listen to the voice coil signal here. And your instrument is isolated away from here. So if I did that, if I chose to do that, I don't know if this would. I'll try this. We'll hook up the oscilloscope here and see what we get on it, because I tend to always do this kind of thing by hooking up back here, basically output of the diode here. But because of my concerns about grounds and stuff like that, yeah, I didn't really cover that properly. Let's go over here and see if I can realize my concern. So the problem here is I have an instrument grounded to the chassis. And I think, is there some instructions? I don't know. I didn't see the instructions for that. Resistance, impedance, power line, voltages, subsets. And then up here was instructions. Where they go? And go on the other page here. The instructions. Snapping coils. Insert the line cord here. Do not remove tubes when set is turned on. Top view chassis. 2 whips. This is showing how to do the adjustment that's coming. Feature set signature 31. Use accurate signature. Set the volume control maximum. Connect the output meter across the speaker voice coil. To avoid AVC action, use the lowest setting. Look, where do you set? Where does it say to set up the oscillator? This is an important thing here. Local oscillator frequency is higher than the signal frequency on bands 1, 7, and long wave, band 8. The local oscillator is lower than the signal frequency on all other bands. This is a really important factor. This gets messy. I found this messed up on radios in the past. First, remove the baffle board and dial assemblies. Let's see. Yeah, I think I've already done them. But yikes, I don't want to read about that stuff yet. What's this? Isn't the instructions up here? No. Okay, I saw just what I needed. Right here. High side through 0.1 microfarad capacitor to stator plates of center section of tuning gang. Low side to chassis. That's what I wanted to see. Now what if I don't do this? What if I stick the low side onto the B minus? I don't like it. I don't know the answer, and I don't want to try it. So what's the alternative here? We'll try the scope on the speaker and see what happens. Okay, scope is on the speaker now. Unfortunately, this means we have to listen to the radio thumping away with the sweep going by. Let's power on the radio. Turn up the volume. I'm pretty sure what we're hearing is the sweep. Let me stop the sweep here. Oh no, it's not. Let's make it show up. me start it up again. Oh, what a mess. Where'd this horrifying hum come from? Who's doing this? A scope connection? Really? What happened to your radio? Where's all this coming from now? I had to have it turned up awfully high. Hoping for any radio station to come through. Okay, I'm gonna stop for a minute and then we're gonna revert back to making sure the radio's operating before I continue on with this. Not working out here. Not working out. After consulting with my assistant here, I've concluded that I've simply bit off more than I could chew, trying to do a sweep alignment, so I'm reverting back to just using a single frequency, fixed frequency signal generator, that guy. And in the meantime, my cat is showing up here. Right? Hey, buddy. Yes, we need some cat time, a little bit of cat time here. I tell you, man, I think if I didn't have these cats, and we have 3 cats, I've got 2 that look like this, and then 1 black cat you don't see very much. If it wasn't for those cats, I don't think my wife and I would be as happy or as emotionally secure as we feel. And yeah, we're feeling a little insecure like everybody because of what's going on, and we don't know where the world is going, and you know, that's what generates anxiety, right? Anxiety is when you can't control your future, or you believe you can't control your future. That's why it's so important that we always have some sense that we're in control, even if we manufacture that sense as much as possible. In control. And that's very much, you know, on a national level, that's kind of what our political leaders have done here in Canada. While we're under attack by the American government, our political leaders have sent the message very clearly. You know, we are in charge of our future, nobody else is. We can do more for ourselves than anybody can ever undo. And that message drains out some of the anxiety that we would be feeling here otherwise. There's an awful lot at stake here for Canada, and for all of us who live here. So it's easy to become very, very anxious about the situation because you have this sense of no control, and you know, Mr. Trump is very good at generating a sense of no control because he constantly moves the goalposts around and everything's going this way and that way. Okay, enough of that. Let's get back to what we're doing here. Yes, you see? See, the cat is working on me right now. Hopefully it's working on you too. And if you're American, I'm sorry if I sound like I'm, I don't want to say bitter, but disappointed. I don't know what I sound like about this stuff. Okay, let's go. Now, I can't do it with you here. I don't think I can do it with you here. He's really got himself comfortable. Okay, I'm going to stop the video and deal with my cat, and then we'll run the test here. Okay, I've spoken with my cat and told him as long as he just remains calm and cool, he can stay for this next part. Stay calm and cool. No, he's looking at this now. Look at this. There. It's green. Can you see green? I don't think cats see color like us. Okay, of course there is no such thing as cut. It just ain't, you know, I'm sure this happens for you too. Any sudden sound or anything when you're in a shop like this and it makes you jump, you know. Well, you got a new toy, eh? No, not my finger. Okay, here we go. Meter's connected to the speaker. And I don't know how this is. This going to work out? Are you going to live up to your deal? No. Oh my gosh. There we go. Radio's up. Making terrible sound because of this connection. And I wonder if I plugged this into a regular outlet, would it still make this same sound? Well, there's only one way to find out. Let's do it. Now, is there any reason why I should hesitate on this? I don't think so. This has an isolated chassis. It's not connected to the power wire. You're trying to help out there, are you? Okay, so the radio's on. So as soon as I plug, well, actually, the outlet's off. So here we go. I still have this. Oh, take that back. Well, listen to that. It's even louder. Let me reverse it. Wow. Now that hum is because of these connections. If the connections weren't made, the hum wouldn't happen. Are you full of crap, Jim? Let's find out. Okay, radio's all by itself. No, it isn't. Yeah, I got this on the speaker, but the speaker's isolated. Where are you going so excited about? What do you... You think something's happening? Okay, so I'm going to plug this back in. We're going to hear it. Okay, that's a little more like it. Volume's right full. So if I turn the volume down to a normal listening level, no hum. Oh my God, Cat, what are you doing over here? I hate to say it, but he likes to sniff my armpit. He'd bury his nose in my armpit if I let him. Okay. I really shouldn't be talking about my armpits on these videos. That's really not germane. Look out, man. Everything's going down. I'm losing control. Cat on the loose. Camera falling. So how are we supposed to do this? I hook this up. We get the hum. How am I supposed to possibly do this? Well, what if I do try? It's just one lead. What if I try? Where are we plugged? We're plugged into an outlet. Let me unplug it quickly here, because unknown shock hazard. Well, maybe there's more to the speaker connection than I realize. It looks to be completely isolated. And I can see the output transformer right in here. I can see the leads. Oh, you know what? There's a feedback system here. But it has its own transformer coil. It has its own coil apart from the speaker. The speaker continues to be just an isolated thing. Well, an easy way to switch the ground around here is to switch these leads down here behind the Cat, and see if that somehow impacts this hum. Don't think I can do the work with the hum going. Now I'm trying to rely on the speaker, and so a hum in the speaker is going to throw off the alignment process. Before I was going to check it at the AVC point. The speaker situation wouldn't really matter. Okay, you stay over here now? You stay over here now. Here we go. Okay, you can hear the radio's on. Not a lot of hum. That's full volume. just as I thought. Makes no difference which way these wires are. He's getting a little too active here. Oh, there you are. So what do we do? What do we do with this great big hum? We try to overcome it with a powerful, turn down the volume first. I'm being fooled. And then we try to pile drive that signal into the radio so the hum is of no consequence. But when I hook this up, we get a big hum. Don't chew my wires, man. What are you chewing on? Spit it out. No, I don't want you doing that. Okay, with it operating. No. This isn't going to work out. This isn't going to play with the stick. This might get a little noisy. Nope. Okay. That didn't add any hum. Now, where's the wire from the signal generator? Didn't hurt. Didn't hurt. No, it don't help. So, the volume halfway. Let's see if we can... Well, we should be hearing this, shouldn't we? I don't have the... What would you do? Your stick fell down, buddy. Here. Have a stick back. Modulation, please. We should hear this. We should hear this tone now. Insufficient input. There it is. First thing, oh my God, can you just settle down a little bit? Come on. Yeah, settle down. There you are. I settled you down. So when you listen to the tone, you can tell there's a hum influencing it. There's a hum on top of it, but there's also the tone itself is being modulated by a hum. We could go. You're gonna get a shock probably. You know what? Wow. But now that would be a disaster here. If the cat got a shock, I don't know what, but I could go through the ceiling and take me with it. So we can pound a stronger signal into the radio. Pounding. Now you can really hear the hum that's associated with the signal generator. Let me cut the signal generator away. You can see how much it's coming from there. Now, is that from the signal generator itself? I don't think so. I don't really know exactly what is going on. I'm so badly distracted. What are you doing? Can you possibly align a radio with this kind of nonsense going on? Let me take the ground off here. So the way I envision this, and this may not be right at all, this hum problem that we're hearing now, the radio's plugged into a transformer. It's not plugged right into the power system. So you have an isolated electrical system from the secondary of the power transformer all the way to here through my switches and stuff. And that is just floating out there. You can think of it like an antenna. It's like an antenna. And so basically a radio is plugged into a type of antenna. When it's plugged into the wall, there is no antenna effect. The wall circuits are grounded. There's a ground, there's everything like that. I think it's a totally different thing. So which is why I wanted to try plugging the radio into my outlet here. I got quite a surprising result, but I think that was still with equipment attached. You know, I could align it like this. That would work. The interference is minimal, as long as I keep the ground off. And we should be seeing something on here. Okay, so we're set. We're set. We're there. Where's my tool, buddy? Here it is. Now, I'm going to make sure this is 455 up here. For it to be 455 in reality, this should read 454. So there we are. Now we want to maximize this meter. I'm going to start with the troublesome IF. Get my fingers in there and steady it. No. There, I'm engaged with the slug now, watching the meter. That's it. We got it there. Okay, now do the bottom. My finger on here. Up and up and up and up it goes. That's about it there. Okay, we'll do this one. Very clear peak on this one. And underneath. I'm going to guess the weird tones you hear in the pitches that are drifting down in frequency and doing weird things, those are vibrating elements in one of the tubes. That's what we're hearing. This is right on also. That's it. The IF is tuned up to 455 the way it should be. Take this off. Wasn't far out. Well, I shouldn't say that. The one, I turned quite a bit on the one, but it seemed like the one transformer didn't make much difference. You move the slug a long way and have a very small effect on there. Big Why don't we, at this point, it's probably wise again to play the radio, go through the band, see what they sound like, and kind of get grounded. The next alignment steps are very difficult, and we don't want to jump into them unnecessarily. If the radio is working really well, it's done already. Yeah, that's the next step. Just play the radio. Okay, let's run through the broadcast band here. So it's hooked up to my outdoor antenna. Volume down. Power on. Okay, broadcast band with the boosting antenna. You can see where it is there, that coil, the yellow coil. I guess the fact that you have to boost to get anything out of this radio is a good indication there's still some stuff wrong here. Let's see what we get. Hey. That's really, really weak. This is 740. You can see it's right on 790. It should be over here. Also see the the noise level is much higher here, as if the radio is more sensitive. I'm not sure that's really what's happening there, but this is 820, and you can see it's up at 880. This is 860 at 9. So, that's quite acceptable. If I pull out the boosting antenna rope, gets nowhere. It's just getting nothing. I'm not even sensitive to my fingers. Barely hear it there. Okay, booster coil back in.
En théorie, sinon il est exactement. Exactement. Donc je pense qu'il fallait quelques flyers, puis il en faut quelques.
Okay, enough of this. Notice can you see the color indicators are incorrect here? Now, is that because this plate just stuck? Sometimes the shifting plate here sticks a little bit. Doesn't seem to be stuck at all. Okay, so let's go the other way. We're going to go to the limit here first. No, that's this way. This way to the limit. That's the limit. And the indicator here should be all white, indicating we're on this band in the middle here, this long wave band. This should be broadcast band. Down here, band 7. Now there's no color showing. Good. Now we're showing a color in here. I think it should be up here, not where it is. Yeah, we'll go right to the top. I got a big powerful tool here. I got to be a little bit careful. That's the end of the run. So the red thing is partially in the 3. It should be up here in the 1. There's a plate sliding here. A spring here. You can see this spring here pulling on a string, pulling this panel this way. And then as you change band, there's another string or something pulling it the other way. I don't see the other thing. It's in there somewhere. Well, that's not going to help either. That makes things quite confusing and uncertain. So I believe right now we are on the top band. So if I put the signal generator at 2.5, because I don't think we're going to hear, well, you never know. Well, no, we do know. This range is not going to have anything on it. So if that's the case, we're at the top, we can come one down, and I'm on the 20 meter band, and we should be able to hear some stuff there if the radio's working. So I'll bring it down one band. So I think I'm on the 14 megahertz band. So we're gonna, oh yeah, check it, see what we can hear. If anything, I don't hear anything. No radioing at all. No surprise. How come it's causing that noise? I'm on a different band now. Maybe that's why it's a little more noisy. Turn it down. Put this on over here. And we'll dial this up to 14. I'm gonna put away this. There you go. Okay. 14 here. 14, and where am I sending it? I'm sending it into the loop. Oh, that's no good. We have to send it into the radio itself. We have to turn this way down. We're going to send it into the where the loop and where the rod antenna is. Just going to do it like this. Going to leave the ground just hanging out there because it's hanging out there. What's all that static? I think I'm shorting this to ground here. Okay. So we're dialed in at, I'm thinking, 14.8. Are we really? I could be totally wrong. Okay, this is a really strong signal. There it is. Get it there. 14.48. 14.5. 14.7. This is probably the right one here. So I hear two peaks. As I go through it, I hear a peak and then another peak. And we're just blasting a signal into this radio like that. Just a whopper of a signal into here. Is there a chance I've mistaken the band and I'm just ramming signals into this radio and getting a result that really doesn't mean what I think it means? So 14.7, 14.7 is way over here from here. When you blast a really strong signal into a radio like this, you can get weird effects, overloading things. Or you can hear signals you would never hear normally. They just would never appear. Well, let's go down. Next band would be 17, so we'll go down one band and we'll check that one. That's up. This is down. Okay, so now I think, even though this one is lit up, I think I'm on the 17. So we'll go 1750. 1750. It's pretty easy to conclude that there's something really blocking the front end of this radio. Because that's just a gigantic signal I'm feeding into it. And it's barely causing the radio to react. Something very seriously wrong with the front end. And that's been kind of displayed the whole time I've worked on this radio. Always needed a very strong signal to get anything through it. That's probably what we should chase down next. It seems to be the same on all bands, so can you attribute it to alignment? Probably not. Let's just put this back down. We'll just keep going. Next band. So now I think I'm at 9. I think I'm around 9.5. That's right on the cusp of the band change here. So there's a very strong, not always, but quite often a strong shortwave station at 330. Just a little bit this way. Can you hear it? Let's put an antenna on here. That's easy to do. Just take this here. Receiving with this as an antenna. Okay, we're going to plug it in over here. Well, that didn't help one bit. What's happening here? How can I pick this up So I do not have the ground connected, but then I'm using the whip input. That should have made a huge difference. What I mean by that is plugging it in over here. It's better like this. How does that happen? How can that happen? She's working good. Did I not turn the antenna on down here? Maybe I didn't. Maybe I left the antenna switched off. Okay, let me, I'm gonna go down and just make sure the antenna's switched on. Okay, of course the switch is thrown. The antenna is live. This is live. It has to be. I used it on the broadcast band and it really boosted it up. What's happening here? That I've got it connected to the whip antenna and it's just... this one. I'm noticing all the different hums that are happening while I'm doing this and wondering how much of the hum we're hearing out of the speakers just from weird way of connecting up antennas and stuff. Okay, volume check. So 180. Hey, where'd it go? My clip lead keeps shorting on the chassis here. Okay, let's try that again. 0, halfway. So it should be pretty loud at this point. Most radios are. That's full blast. Fading out. Did you hear what that was called? Did you catch that? Pretty. I think it said World Last Chance Radio. Well, there's no question that these markers are out. Probably an easy thing to fix. There's no question the radio is very weak. And this is out by about that much. Let's go on another band. Next band will be, wrong way, would be this one. So we can set the signal generator around 5 megahertz. Okay, I'll go back to the signal generator because I'm pretty sure we're not going to pick up any signals at that frequency at this time of day. That signal we were listening to is one of the strongest shortwave signals, 9330, and it's usually there. It's usually there. Okay, so we're on 5. Sounds the same. 5. Where are we actually? So if everything's happening the same way, then we're tuned to 4.9, but it's probably closer to 5.2. Now this might have something to do with the local oscillator being above and below, causing this. about the same. Signal strength, very weak. Because this would be, this setting here is comparable to like the strongest thing you'd ever pick up on your antennas. That's kind of that kind of signal. And you barely hear it here. Okay, let's go another band. Might as well finish this off. Okay, so now we're down on 11. Hey, we can pick stuff up here on 11, but let's try first with the signal generator, about 11.6. 11.6. You hear my coffee maker saying it's finished. We didn't hear it. I didn't have it turned up. Just 1 second here. Everything's okay. Try it again. We're at 11.6. Where are you? Right there. You probably didn't hear it, but I did. So 11.5. This is 11.5 here. So similarly, it's just out. This time it's, I won't say it. Okay. Where are we at now? That's the end of the run, isn't it? There's a long wave thing. I've only recently become really aware that long wave was an important thing in Europe. It meant nothing over here. Now that should be here at 26, let's say 30 what? 30 kilohertz? 180 to 400. So this would be 260 kilohertz here, or 300. So let's go with 300. Right near the word Finland. I think all these words here go with this 31 meter band. Finland. Never seen Finland on a radio before. 30. 300 kilohertz. 300 kilohertz. It's right on the band change again, so let me move this. Let's try 250. 250 kilohertz. 250. I didn't hear anything. Probably not going to dwell on this too long. Output from the signal generator has gone low. That's what's happened here. Okay, I'm going to put this up. Actually, we got to do this. Do it properly, Jim. Okay. Let's see if we can hear it this time. Where am I dialed in? I'm dialed in at 250. A very strong signal. Does this use the loop antenna when you're on long wave? I don't know. I don't know. We're not hearing anything anyway. I'm not going to dwell on this one. There's nothing to hear there anyhow, except noise and stuff. Okay, switch off. What's the conclusion here? Well, the conclusion is it's weak all the time, and I've got to guess that there's something that is uniformly affecting all the bands, something in the front end. What that would be exactly, I don't know. You might want to poke at the idea that the RF amplifier is weak itself, but I've tested the tube. The tube is good. And the challenge here too is a lot of the front end stuff in this radio is inside this box and quite inaccessible. So another possibility is it's just bad alignment all around. It's somebody's fiddled with these, you know, doing stuff, and it's just everything's just so far out. Well, there are some adjustments I can make here without digging down into this box. I just pointed to these guys here, and you know, is sometimes people fiddle around with these. And these screws are attractive for fiddling. These are not really, usually this is not a high impact alignment issue. Like it's not enough here to completely discombobulate the radio or make it really, really weak. But I don't know. Who knows? I don't know. Talking through my hat. I think what I'm convincing myself to do is to find some more stuff to fool around with without getting deep into deep inside this thing. There's this weird adjustment here. I'm not sure what that is. People could have fooled with it. Actually, I'm the people who's fooling with it. Okay, thanks a lot for watching. And tomorrow we'll just try to get this guy. We'll try to solve the apparent front end weakness in this radio, or prove the weakness is in the front end. See ya.